Last class actually I completed the different categories of power sources, especially last class I have completed the static characteristics of different welding power sources. Today I will first make a comparison between these static characteristic power sources like constant current and constant voltage characteristics, what is the comparison or difference between them. Then I will go for dynamic characteristics of power sources. So, first of all, last class actually I have already told you that there is generally two different types of power sources. Last class I have completed on static characteristic power sources, that is there we have seen there is generally three different categories of static characteristics power sources. One is constant current CC, another one is constant voltage, and another last one is combined characteristics power sources. The next categories is remain, which is called dynamics or pulse characteristics of power sources. This I will discuss in details in today's lecture. Before going to discuss about dynamic characteristics or pulse characteristics of power sources, first of all I will just briefly discuss about the comparison between constant current characteristic power sources and constant voltage characteristics power sources. So, for that generally I will just briefly discuss about these things. So, generally constant current CC, it is represented constant CC, and constant voltage is represented as constant voltage. So, what is the comparison or differences between these two? First of all we will discuss briefly here. After that we will go to dynamic characteristics of power source. Generally constant characteristics power source is look like a constant characteristic power source curve is look like this. This is also called drooping characteristics, and constant voltage characteristic power sources is look like where voltage is remains almost constant, voltage is remain almost constant. Now, here generally this point is called V0, or you can say this is generally called open circuit voltage of the power source. Now, from these two power sources what we can observe here, a small change of voltage, a small change of voltage means a small change of arc length. That means, if here a small change of voltage is occur, that means that the voltage is delta V. Here generally a small change of current is occur. Here generally change of current is small, whereas here generally in this case for flat characteristics or constant voltage characteristic power sources, here generally for a small change of voltage like this delta V, here generally current change of current is comparatively very high as compared to constant current power source characteristics. So, what are the difference between these two characteristic power sources? Here generally rate of melting is almost constant, but here in this case rate of melting can vary, arc length remains constant. How we can observe from here? Because you see here a small decrease of voltage, here a small decrease of voltage, a small increase of current is occur, whereas here generally a small decrease of voltage, large change of current is occur. So, here generally melting rate is not constant, but here generally if the arc length changes, then here generally due to this more melting, here arc length remain constant in case of constant voltage power source characteristics. Second thing, Here in case of constant voltage power sources, OCV, that means open circuit voltage, is higher than constant voltage power source. Here open circuit voltage is comparatively smaller than constant current power source characteristics. Now, here third point is self regulation, self regulating characteristic is not available, That means, if here generally self adjustment of arc length is not available, that means if the arc length change, that arc length remain more or less same, but here generally self regulating of arc length characteristics of is available, self regulating of arc length characteristics is available. So, here generally arc length, if there is a change of arc length in case of constant voltage power sources, here generally if there is a constant in case of constant voltage power source, if there is any shortage of arc length is there, then there will be shortage of voltage. Due to this small shortage of voltage, there will be comparatively high change of current is there, or high increment of current is there. Due to that, generally more melting of filler oil is taken place. So, what happens here, this arc generally length regain to its original position. This is generally called self regulating of arc length characteristics. This is available in constant voltage, but constant current is not available. Generally, is this constant current power source characteristic used in manual metal arc welding, MMAW, or we can say this is also called SMAW. SMAW, generally manual welding process, generally this is used, and generally this is used in automatic arc welding process, generally this constant voltage power source characteristics is more applicable. Because here generally if there is a constant automatic power source, generally if there is a constant, here generally we can maintain constant feed rate of consumable filler wire in case of constant voltage power source characteristics, because generally here self regulating characteristics is available. That is why it is used generally in automatic arc welding process. It is generally used for manual arc welding process. It is generally used for manual welding process. This is also used for non-consumable electrode, that is GTAW, or plasma arc welding process, where generally non-consumable electrode is used. Non-consumable electrode welding process, generally this is used. Non-consumable electric process used in non-consumable electrode welding process, because what happens generally during starting of the non-consumable electric arc, if the tungsten touch the workpiece, then if there will be huge, there will be generally voltage will be that means during shorting of the electrode with workpiece, there is generally voltage reduced tremendously. That means voltage reduction is very high. So, if we use these types of this constant current power source, then there will be current source will be a smaller side. So, what happens here, there will generally chances of accident will be less if we use constant current power source characteristics. Chances of accident in that sense, chances of instability will be less if we use constant current power source characteristics. But generally these constant voltage power source characteristics used in consumable types of electrode, consumable type of electrode welding, used in consumable types of electrode welding process like is submerged arc welding process, where generally electrode carry current as well as its melt and consume in weld zone. Then GMAW, that means MIG welding process, or GMAW process, generally these types of welding is used. So, this is generally a comparative or comparison between constant current power source characteristic and constant voltage power source characteristics comparison, or we can say this is the difference between constant current and constant voltage power source characteristics. So, we got a very good idea about constant current characteristics power source and constant voltage characteristics power source. Now, we will go where we should use which welding technique actually, that means what types of power source we used for a particular types of welding process, that also we should know. That means power source selection, how it is done. We know that no single power source is right for all welding situations. It is necessary to know the process to be used before selecting the best power source. So, first of all we should know what process is going to be used, then only we go for power source selection. Like here I am showing some welding process name left side, and here what types of power source characteristics we should choose, what types of power source characteristic we should choose, that also we should know. Now, generally shielded metal arc welding, SMAW, this shielded metal arc welding, it is generally a manual welding process. So, what we observe from the previous discussion of constant current and constant voltage characteristics, generally shielded metal arc welding is a manual welding process. So, here generally we should prefer generally constant current power source characteristics. So, here generally constant voltage characteristics is not preferable. Similarly, gas tungsten arc welding process. Gas tungsten arc welding generally is a non-consumable welding process, non-consumable electrode welding process. Here generally electrodes carry only current and it is responsible for generating the arc, but it is not melted or consumed inside the weld zone. So, what happens, this is a gas tungsten, here generally electrode is electrode should non-melting one. That is why in case of gas tungsten arc welding process, we should use constant current power source characteristics. Here also we should not use constant voltage power source characteristics, because constant voltage power source characteristics is not preferable for generally non-consumable electrode power source characteristics, what I have already discussed in previous slide. Now, gas metal arc welding process or MIG, or this is called MIG or GMAW process, metal inert gas welding process, or this is a generally automatic welding, especially it is a automatic or semi-automatic welding process. Here generally it use a consumable electrode. This gas metal arc welding used a consumable electrode. That is why these gas metal arc welding techniques generally we should use constant voltage power source characteristic. Here generally constant current power source characteristics is not preferable. Similarly, pulse gas metal arc welding process, here generally constant voltage is not preferable, because there is a pulse of current is there. Here generally constant current power source characteristic is preferable. Then flux core arc welding process, flux core arc welding process is also a consumable arc welding process, where generally this as the flux is inside the electrode, that means here the a metal core is available outside the metal core is available inside that metal core generally flux is putted. So, what happens here, this flux core arc welding is a consumable automatic welding process. Here generally this electrode can be automatically feed also, and it is a consumable welding process. So, this welding process, as it is automatic and consumable welding process, here generally constant voltage power source characteristics is preferable. Here generally constant current is not preferable. Then submerged arc welding process, it is generally a consumable and automatic welding process, submerged arc welding. So, here also constant voltage power source characteristics is preferable. Generally constant submerged arc welding process, this constant current is not preferable. So, similarly electro gas welding process, electro gas welding is a such a process, here generally both the techniques, both the characteristics we can apply, that means both constant current power source characteristics we can apply, here generally constant voltage power source characteristics is also applicable. Now, electro slag welding process, here generally constant voltage, it is also a automatic process and consumable electrode process, here generally constant voltage is preferable, but here generally constant current is not preferable. Similarly, plasma arc welding process, this plasma arc welding process is, here generally this electrode is non-consumable, here generally a tungsten electrode is used. So, that is why generally this plasma arc welding techniques, constant voltage power source characteristics is not preferable, here constant current power source characteristics is preferable. So, we got the idea actually for which welding techniques, what power source characteristics we should use. So, we can easily see, we can easily observe from this chart, these are the generally widely applicable conventional welding techniques. Once you will be industry, then you will see these are the conventional welding techniques which are generally widely used in industrial application, especially manufacturing industry. Now, we will go to dynamic characteristics of power source. So, we already discussed in details about the static characteristics of power sources. Now, we will go what are the dynamic characteristics of power source. In case of a static characteristic power source, the output is not transient, there it is not, generally there are transient variation, or generally there is not rapid change of current and voltage is not there, or generally this output is not depends on time, that means output is not generally this output variation in case of static power source characteristics is not depends on almost time. That means in a static characteristic this change of voltage and current is that means output voltage and current does not generally change with current rapidly. But in case of dynamic characteristics power source, generally this change of current and voltage change rapidly. So, it is generally it is the rapid transient variation of, here generally we observe the rapid transient variation of output current and voltage. So, generally these types of rapid change of output current and voltage occurs in case of short circuiting drop transfer, generally where the drop transfer is occur due to short circuiting of the arc, generally there we observe these types of dynamic characteristics of power source. Generally then arc starting also there is a rapid change of output current and voltage is observed, and arc reignition, generally in this following situation we observe generally dynamic characteristics is very much important, because here generally rapid change of output is there, that means here output, that is current and voltage, which is depends on time, which is highly depends on time. It is a transient variation, and this transient variation is rapid change actually. Generally to cope up with the short circuiting, arc starting and reignition, generally reignition power source should have good dynamic characteristics should be there to cope up with this above said condition. For that, because otherwise we will not get a stable or smooth arc. So, if a power source have good dynamic characteristics, then we can get a stable and smooth arc. So, that is why generally power unit for short circuiting or short arc welding usually incorporate an inductor in their output. That means to stable the arc, So, for the stability and smoothing of this arc, generally a inductor is used with output of inductor is used generally with output of the dynamic characteristics power sources. The function of a inductor, that means power unit with short circuit or short arc welding usually incorporate an inductor in their output. The function of a inductor is generally if the voltage changes or voltage reduce tremendously due to short circuiting, then the current surge or current rise will be slower. That means here the function of a inductor, that means slower the current rise, because if the voltage reduce due to short circuiting is rapid, then the current surge will not be rapid. Here the current surge will be slower. That is why generally the function of a inductor is used in case of dynamic characteristic power sources. Now, if this current surge will be more, then what will be the problem? If the current surge of a arc, if it will be more, then there is a chances of high electromagnetic forces. We know that if there is a flow of current, then there will be generate some electromagnetic force around the arc. So, this if there will be high surge of current will be there, then there is a chances of high electromagnetic forces. So, to generally if there will be high electromagnetic forces, then this arc will not be stable. So, there is a chances of spattering of the arc. Due to this spattering, there will be the spattering of the molten pool also can be there. So, that means to avoid that spattering effect or to stable the arc, generally a inductor is incorporated. If we use a inductor in the output of this characteristic power source, then what we can get? Here we can get a smooth and stable arc, because due to this inductor the rise of current will be much slower. Now, here generally I am just showing generally what is the function of inductor with output current or voltage output current. Here I am just showing a figure, then you will get a very good idea from here. This is time t, this is time t. Here generally I am showing two figure. Here generally here this axis represent let us current I. So, how the current is varying? These are the general dynamic characteristics of power source characteristics. This is one figure I am showing, another figure I am showing. Here you see, in this figure generally the variation is very rapid, means here this variation that means number of pulse rate is very high. Here generally pulse means this each and every peak is called on pulse. Generally every heap and peak is called on pulse. So, this pulse generally this rate of pulse is very high. So, and in this case the rate of pulse is comparatively low. That means here the current change, in this case the rate of change of current or change of current is generally rapid, comparatively rapid than in this case. Here generally change of current is slower. Why this is happened? This curve here, this is happened due to the application of a inductor. In this first figure generally here the inductance is low inductance due to the if the inductance is low, then there is a high rate of generally there is a high number of pulse rate we observe. If the high inductance is there, if the high inductance is there, then there is a slow variation of current is there. So, this is the means application of inductance or inductor of the output current with time. Now, this dynamic characteristics power source, sometimes it can be referred as pulse mode power supply also. Now, what is pulse mode power supply? Pulse mode power supply also is a DC direct current power source but here the output is pulsing mode. This is also direct current power source, but its output is in pulse mode. This pulsing, or that means this rate of change of current or voltage, which is not arbitrary here. Here generally this pulse mode is predetermined. That means what should be the number of pulse, that is predetermined. Here this pulsing is not come arbitrarily. So in pulse mode power supply, here we can put the number of pulse, what should be the number of pulse per minute, or what should be the number of pulse per second, that we can predetermine. So accordingly this number of pulse we can control the deposition rate, means per second how much metal deposition should be there, or how many droplet transfer should be there in whirlpool, that we can control by this pulse mode power supply. How it's look like, that I am the little bit explaining here, then it will be very clear to you. Generally pulse mode power supply is a DC power supply. Here generally this transient variation of current which is pulsing in nature. How it's look like, just I am just showing it roughly. So this is generally pulsing mode of power output, that means this is a pulse mode. Now this has not a zero current, actually in this pulse there is no zero current. So this lower current is called background current, or minimum current of this pulse is called background current, and highest current of this pulse is called peak current. And the duration of peak current, duration of a pulse peak current is called peak current pulse, and duration of the duration of one background current pulse time is called background current pulse. Current pulse. So generally here one thing you keep it in mind, generally in this background current is set in such a way so that this arc will not extinguish. Generally what happens in case of alternating current, there is a zero crossing for every cycle of the current, there is a zero crossing. So every time there is a extinguishing of arc is there, but in this case this background current is set such a way that this arc will not extinguish during this welding operation. And this peak current is set in such a way, this is generally responsible for droplet transfer. That means in peak current generally molten droplet will transfer. So here generally this number of pulse, that means peak current and background current, generally this number of pulse we can predetermine. So according to our requirement of weld deposition, this number of pulse per second or per minute what it should be, that we can predetermine. So we can control the deposition rate in case of pulse mode power supply. So this is also generally what types of power source, this is also DC direct current power source, because here there is no zero crossing of the current is here, but this DC current, but this is a pulse mode. Now here so we discuss about static characteristic power source and dynamic characteristics power source. Some others important note is also available for power source, welding power source. About this important notes I will discuss briefly in subsequent slides. So first of all, generally apart from this above characteristic or above power source, above characteristic power source or above discussed power source, there is used generally in modern technology, there is used some other very important power source. That power source generally is a very latest development, the latest developed power source we can say. This is a generally advanced development, this is not a latest actually, this is a advanced development of welding power source, which is generally operated by transistor. So, here generally we can control the output as per our requirement. Generally here this transistor power supply unit, that is generally called transistor power supply unit. Here generally a transistor is used to control the welding output parameters. That means as per our requirement, this transistor generally change the signal and it can regulate the welding arc, and here it can do the welding operation as per the requirement of as per the requirement. Now, here generally this power source, how it look like, that we should know. What are the different component is available in this transistor power supply? This is a generally advanced types of welding power supply. Whatever the traditional welding power supply, as I told already, I discussed, this is generally advanced types of welding power supply. Here generally this power supply circuit diagram we can represent in this way, like here generally this power supply circuit diagram I am just drawing. Because this I will explain in details, then it will be very clear to you. This is also generally, this is main supply or utility supply. Generally here generally DC current, this is a transformer, here generally this is a rectifier. So, from here generally this DC current first of all I draw it, then it will be very clear to you. How it's look like that, once you will get the idea, then it will be very clear to you. So, this is generally direct. So, this is generally TR, or you can say TR is transistor regulator actually, transistor regulator. This is generally transistor regulator. Now, here generally there is a main supply, from main supply it goes to, it generally convert this, it goes to transformer, then it goes to rectifier which convert this AC current to DC current. This is generally arc, this is workpiece actually. So, here this is called feed system, this is generally called reference setting, and there is a generally called command, this is called command unit actually generally. So, how it's look like? So, once first I draw this circuit diagram, then if I will explain, then it will be very clear to you. So, here generally here this extra part is there, that means transistor C is stand for command unit, then F is called feedback, F is called feedback voltage or current, generally it is generally feedback the voltage or current, it generally feedback the voltage or current. Generally S is called reference setting. So, first of all I draw everything, then TR is called transistor regulator. Then what happens here? Here generally first of all this DC current goes to transistor regulator, then from transistor regulator generally it goes to arc. So, from this arc generally a feedback system is there, then from this arc if there will be any disturbance, then this disturbance, that means if there will be any change of arc current or voltage, then this gives a feedback to this feedback system. So, it takes a feedback from feedback system and it takes from feedback system and it goes to this command unit. So, in this command C, command unit is go. Similarly, some reference setting also we provide, where generally reference setting also goes to command unit. Now, thus input from reference setting, input from this S and F, it goes to command unit. In this command unit, the function of command unit generally find the error between this feedback and reference setting. This error generally it amplifies here and it gives a signal to this transistor regulator. This transistor regulator generally then control the output according to the requirement of welding process. So, here generally this transistor take the signal from command unit. This command as per the required signal of command unit, generally transistor regulator transistor regulated the output signal of the arc. So, here generally output control is very carefully we can do by using this power supply unit. Generally this is the complete circuit diagram, this is the generally complete circuit diagram of transistor power supply unit. Generally several modern arc welding power supply unit contain this transistor, or this is sometimes called solid circuit power supply unit. This is used for regulating the output or generally replacing this power source unit can replacing the reactors found in conventional system. That what I have already discussed, that means 3 different types of reactor which generally used in case of AC current. They are what we discussed, they are generally used 3 different types of reactor. So, by using these types of transistor power supply unit, we can eliminate that reactor set also. Now, it consists a feedback system, what I have already told you, it consists a feedback system whose for regulating the welding parameters. So, according to this feedback system obtained from this arc, if there will be any distance, generally this feedback system give feedback to transistor regulator. So, transistor regulator automatically control the voltage and current in the arc region, in this arc region. So, what happens here generally due to this consistent of as it consists a feedback system. So, here generally regulating the welding parameter, here generally we can control the welding parameter, or we can regulate the welding parameter as per our requirement. This transistor can be made to behave as variable resistance in response to command signal. So, this transistor we can be made to behave as a variable resistance in response to command signal. Due to this variable resistance, this generally this power supply unit we can use as a constant voltage power source for GMAW process, like gas metal arc welding process, as well as this power supply we can use in case of constant current output for GTAW process also, because this thus the same power unit can be made to work as constant voltage source for GMAW, and simply by changing the command signal it can be made to give CC output to GTAW process. So, it can be made to give CC output or constant current characteristic output to GTAW process, means gas tungsten arc welding process. Apart from this thing, in some cases this transistor power supply unit also can reduce the fluctuation in main output voltage. That means it can compensate the fluctuation in main output voltage also. That is why by this power supply generally we can get a stable and consistent operation of arc. So, by this we can get a stable and consistent operation of arc, or this provide a stable and consistent operation of arc, especially in GMAW process. Now, as per the requirement, generally this power supply can provide accurately controlled pulse. As per our requirement, this power supply can provide accurately controlled pulse also. So, it can also be used in pulse GTAW or GMAW process also. That means pulse mode power supply. So, this by using this power supply we can get constant current constant current power source characteristics. By this single unit we can get constant voltage power source unit, or by this power supply we can get pulse mode power supply output also. So, this is a very advanced level power source unit. So, this all about different power source which generally used in conventional welding processes. Now, we will go some other important note which we should know in details, like here generally in case of power source what we can observe. In case of power source generally we can observe there is use to feed the electrode. Generally we see in case of continuous, in case of to feed the electrode, to feed the electrode to the feed the, this is called generally this generally electrode which generally wounded is a roller, this wounded is a generally wheel, this electrode generally owned with a wheel. Generally this electrode generally have a speed which is controlled by some feed roller. This is called feed rollers. So, by rotation of this roller generally what happens, speed of this consumable electrode, speed of the consumable electrode is maintained. Now, this feed roller drive system, this feed roller have some drive system, this feed roller have some drive system. So, by this drive system we can control the speed of the feed roller. That means, by this drive system we can control the speed of the feed roller. Sometimes this drive system is generally give constant speed, sometimes this drive system can give variable speed. So, depending upon this output of this drive system, generally there is two different types of wire feed system are available. What are these two different types of wire feed system is, one is called constant speed feed roller system, another one is called variable speed feed roller system. Generally in case of constant speed feed roller system, here the feed roller rotating at a fixed speed, generally which is used for pushing or pulling wire to feed into the weld, so as to maintain the arc length during welding. So, generally this feed roller is used to movement of this consumable electrode. So, here generally what happens, due to this pushing or pulling, due to this constant speed feed roller system, due to this pushing or pulling, this roller can move downward direction, rotate downward clockwise direction as well as anti-clockwise direction. So, generally by pushing and pulling we can control here the arc length, but this roller have a constant speed. This roller generally provide a constant speed of filler wire. So, these types of constant speed feed roller system generally used with constant voltage power sources in combination with a small diameter electrode. Generally it is used for these types of constant voltage power source. This is let us constant speed, constant, this is generally constant speed feed drive system, this constant speed feed drive system generally used with constant voltage, it generally used with constant voltage power source in combination with a small diameter. Here generally some small diameter electrode is used. So, if we use this feed drive for constant voltage and with a small diameter electrode, then what happens, here we can get a generally self regulating here, and due to this constant voltage power source characteristics, here due to this self regulating characteristics of constant voltage power sources, here generally we can maintain the arc gap. So, here how the arc gap or arc length remain constant, here the arc length remain constant by self regulating characteristic of the constant voltage power source. So, here generally either here the speed of the roller is constant, but sometimes due to some disturbance, if there is a change of voltage or change of arc length is there, that generally compensating by self regulating characteristics of constant voltage power source. So, this constant voltage, so this constant speed feed drive system generally used with constant voltage with self regulating characteristics power sources. Then if the speed of the roller is constant, then we due to some changes, if there is any change of arc length or other thing is there, then due to this self regulating characteristics, it can maintain its required gap, or it can maintain the arc length fairly constant. But in case of variable speed power source unit, in this case generally feed roller used for feeding the electrode wire are rotated at varying speed as per need to maintain the arc length during welding. These types of power source unit generally used for automatic welding process, especially in submerged arc welding like GMAW welding process, consumable types of welding, generally submerged arc welding, that is consumable electrode welding process, generally these types of variable speed drive system and little bit as advanced welding process, generally submerged arc GMAW welding process, generally these types of variable speed feed drive system we can see. Here generally fluctuation in arc length due to any region is compensated by increasing or decreasing the electrode feed rate. Here the generally here fluctuation in arc length due to any region is compensated by increasing or decreasing the electrode feed rate. Here the electrode feed rate is controlled by regulating the speed of the feed roller, which is powered by electric motor. Here generally input power to the variable speed motor is regulated with the help of a sensor, which takes input from fluctuation in the welding arc gap. So, once generally this how this variable speed power drive is look like, the variable speed power drive is look like this is generally feed roller. This generally feed that electrode, this is generally consumable electrode. Generally in this power unit, in this drive system, generally there is a contact tube, there is a contact tube. Here generally contact tube is there. So, this is generally feed roller, this is generally feed roller. This feed roller generally derived by a system, this feed roller generally operated by a motor. Generally this motor is variable speed motor. So, here generally like in previous case constant speed feed drive system, there the speed of the feed roller is constant, but here the speed of this feed roller can be variable in nature. So, here if there is any change of this arc voltage or arc current, generally it gives a sense, by a sensor to the electric motor, generally this gives a sense by sensor to electric motor. So, by this generally motor get the power, and according to this sensor sense, this motor control the speed of the feed roller. So, this generally feed roller is controlled by the sense which is collected by a sensor. This sensor generally sends the input to motor. Then according to this sense, this motor control the speed of this feed roller. So, then generally if there is any fluctuation, then generally according to this sense or input from the sensor, this feed roller control its speed, and here generally arc length maintain its constant length. So, here generally self regulating types of characteristics is not available, or self regulating characteristics is not required here. Here generally by controlling the speed of feed roller itself, here generally we are controlling the required arc length. So, this is generally wire feed system. Now, at the last actually we should know little bit what are the wire, generally cooling system and insulation unit used in case of power source unit, that also we should know. There actually once we will be in industry, this types of information also we should require, because let us we are going to purchase some electric power source. Generally there these types of wire cooling system, what should be the wire use of wire cable, what should be the cooling system, what should be the insulation type, we should, so briefly we should know about this thing. If we know this thing, we can get as per our required power source. That means we can get we will not actually, so if we know this thing, then we can apply this knowledge in industry also. Here generally the maximum current which can be drawn from a power source at a given duty cycle depends on what? Depends on size of wire, type of insulation, and generally a cooling system. Generally always we should remember here, generally in case of welding power supply, force cooling system is used. Then what are the welding cable here we use? Generally in welding system, in case of welding, this power cable generally made from anneal copper bar, which is follow a standard that is called ASTM B3 standard. This wire cable, generally this welding cable have a size which is varying from 6 AWG to 5 MCM. Now here we should know what is AWG. AWG means American wire gauge. A for American, W for wire, and G for gauge. Generally this 6 AWG equivalent to around 0.380 inch outer diameter of copper cable, and it can be maximum, it can have a maximum size which is generally within a range of 500 MCM. Generally 1 MCM is equal to generally 0.5063 square millimeter. So, 500 MCM is equal to almost a cable bar whose diameter is around 8 millimeter. This wire generally wrapped inside a non-conductive durable jacket. This durable jacket generally made by thermoset material. This thermoset material especially used for welding purpose is EPDM, or this is called generally neoprene. Now generally insulation, what types of insulation generally used in case of welding power source? Generally insulation is used from overheating of the power source actually. This insulation also have different categories. Generally in case of welding power source, these are the following types of insulation generally used. Like this insulation can be categorized as A, B, E, F, G, H. So each and every insulation have some different composition, as well as it has some different temperature tolerance limit. So these all generally some other small things we should know actually generally. So here generally so at last actually little bit I want to tell, because once what are the different types of power source generally used in toy industry, school industry, and in actual heavy industry, that also we should know. Generally in case of hobby shop, a small welding shop or schools, generally the power source which is used, that power source is called a small power source. These power source generally have a current range varying from 80 to 250 ampere. This small power source, this generally operated by a single phase main supply, and it gives a output which is also AC in nature. So here input and output, in case of a small power source, input and output both are alternating current in nature. Generally this small size power source whose current range is generally within a range of 80 to 250 ampere. So this is generally used in a small welding shop, hobby shop or school, and it has rated at a small duty cycle, that is 20% duty cycle only. Then slightly large or medium power source also is there. It generally, how it's generally categorized, slightly large means here the current range little bit in higher side compared to this small size. Here the current range like varying from 175 within a range, just I am giving a rough range actually, within a range of 175 to 350 ampere. So this generally power source generally have is called slightly large or medium power source. It generally operated by single phase power supply, but it generally its input is AC, but its output can be AC or DC with additional control is also there. This additional control generally required for GTAW process. So this is generally slightly large or medium power sources. The last categories generally which is used in actual manufacturing industry, generally where this current range is also from higher side, current range should be higher side, which generally operated by a 3-phase utility power supply or 3-phase main power supply. Generally this power supply have a current range more than generally 350 ampere, which have a maximum current more than 350 or more current range. So generally this large power supply always operated by a 3-phase input. So these all about the power sources, this all about the power source of welding processes, especially traditional welding processes power sources, its characteristics. This is all about traditional welding power supplies or power source. Next class I will discuss about physics and principle involved in different types of traditional welding processes.